This is part 5 in the series of tutorials for building our Drive app. It is also the third one in stage 2. So by the end of the previous one, we got to just about step number 16 in our guide for stage 2. We attached a script that we wrote. We talked about how that script works, the one that makes the car move and attaches it to horizontal and vertical axis. And we attached the script to the app manager, and then we populated the 3 public fields. We told it that the object to be moved is the one called my player, which of course includes the vehicle and also its colliders and also the camera. We also populated it with, let's call it the horsepower, the forward force, which is some kind of a balance between the car's like the horsepower of the engine and the weight of the car, and also the turn force, which means how fast will it spin or turn when we press the left or right arrows or the A or D keys, or once we have a controller in our hands, push the joystick left and right. We also played in Unity, and the vehicle does move using the arrow keys or WASD, but the wheels do not spin yet. And we said that this would be a good time to build, and that's kind of the last thing we talked about in the last part. So now we are on step 19. The next script we will build is actually going to make the wheels spin, and not just spin in proportion to the z velocity of the car. What's the z velocity of the car? The speed that it moves forward. As I was discussing in a previous tutorial, velocity sometimes sounds like the word speed, and it's very much related, but velocity is speed with a direction, with a vector. So what you're going to do is create a script, and it's going to be called wheel spinner with capital W and capital S, and instead of the default content, you're going to type what it says here in the screenshot. So if you haven't done that yet, now will be a good time to pause to create that script. When I say create that script, it's not part of any existing object. I'm talking about going to the folder, my script, right-clicking, create, new mono behavior script. I already did that, and I got a script called wheel spinner, and I'm opening it, and I'm assuming that if you're listening to me right now, that you already unpaused and you already typed it. So let's understand what you typed. So again, this is for right now. The script is standalone. It's not attached to anything. First we write it, then we will attach it, as you will see, to the 4 wheels or to the 4 tires. The name of the script or the name of the public class is wheel spinner. The only library it's using is Unity Engine. Of course, it's got to match its its name, wheel spinner, capital W, capital S, and the only public field it has is player. Notice that it's not a game object, but a rigid body, because what we're really moving is the rigid body of the player. The player already has, let's go back, the player already has a constant force, and because of that, he already has a rigid body. So what we're moving, what we're pushing, is the rigid body, and with it, of course, the object itself, but also the rigid body is the one that's going to help us find out the velocity. So the only function within the public class is update. In other words, of course, everything that happens here happens 72 times a second. So 72 times a second, it finds out. What does it find out? I'm declaring a var called lockvel, local velocity. And it goes, okay, the player, this rigid body, dot transform, which means it's location, and it runs a function that's built into the Unity engine that comes from Unity called inverse transform direction. And it applies it to the player linear velocity. What does it really do? It goes like, okay, this object, how fast is it moving and in what direction? Because it happens every frame, it can go like, okay, so in the last frame, its X was, let's say, XYZ was 156, and now it's 256. So that means that in one frame, it moved 1 meter to the left. It interprets that way. So that's what that function does. So it interprets by how much did it move and in what direction it moved, and it translates the result of this is what's called a vector 3, or in other words, it comes up with 3 numbers. It's velocity x, it's velocity y, and it's velocity z. In what direction is it moving and how fast? What I added here, and we will test this, is that I can also print it. Print, of course, shows it in the console, is to show localvel, and you will see that it actually will print out 3 numbers. But since the script is not attached to anything yet, this is not going to work yet. So we will go back to this. Then I'm going to ask local velocity, hey, okay, so first of all, out of all the 3 numbers, application data.current z velocity will take its value from the local velocity, this value that I just find out. What is the z? How fast is it moving forward? Apply that to application data current z velocity, because we will use the current z velocity, which is like how fast is it moving forward or back, to control the sound later on too. Also, we're going to use the y velocity. How fast is it moving up or down? Where is the car going to be moving up or down when it falls or when we jump off of things? We're going to use that to make like a thud sound when we fall on things, or a splash sound when we fall into the ocean. So this is why it says will be used later. What will be used right now is transform.rotate. Now, whose transform? The transform of whatever object this script is attached to, and that's going to be one of the tires. So it's one of the tires that will have, or each one of the tires will have this script, and it will say to itself, hey, what do I need to do? I need to rotate. I'm not going to rotate along X. Rotating along X is like, leaning forward. I'm not going to rotate along Y. I'm going to rotate around Z. Now, you might think, hey, isn't it going to rotate around X? No, because it's already shifted 90 degrees. So local velocity Z. And where is it going to rotate? In space.self, or in other words, relative. So wherever it's facing forward, that is its z. It's not the z of the world. Or in other words, when you turn left and you keep going, now that new direction is your forward. So in other words, this last line is going to say rotate this object, whatever object is attached to the script, based on the forward speed. Forward speed faster, wheel spins faster. And it's going to spin inside its parent, which is the wheelbase. And update end class. Then it says that we're going to attach this script, the wheel spinner, to all 4 meshes, not the 4 containers called, front, left, front, right, and so on. Not the wheels, but the meshes. So it even shows you that what's going to be attached is to the, or what we're going to attach the script to is going to be the mesh. As a matter of fact, we could do all of it at the same time instead of doing it, 4 times. What we could do is open up the player, open up the vehicle, open up all wheels, and then open up each one of the wheel containers. Then select mesh. I'm holding command because this is on Mac. If this was Windows, I would be holding control and selecting all 4 meshes. And then I can take wheel spinner and attach it to all 4 of them. So right now, the mesh, which is like, the tire inside the wheel front right, has the script. And also this one, and also this one, and also this one. If you feel more comfortable just, dragging it 4 times, I don't care. The other thing that it says that we're going to do to all of them is all of them are going to ask, okay, I'm a wheel. Who's going to tell me how fast to spin? The speed of who? The player. So I'm going to take the object player and populate it again. Because all 4 of them were selected, I just populated for 4 of them. Or you could do it, one at a time, as long as when you check, they all have the script and the player is player rigid body, which is exactly what it says on the next few steps. For each one of the 4, assign player, which you can drag into the public field player. Save, test. Now, using WASD or arrows, the vehicle should drive and the wheels for spin. For now, still with no steering wheel. So the wheels are spinning, but only kind of like rigid forward. Let's try that. If I play, and it'll be easier to see it from the game window because this is going to fly right out of the scene window. See how the wheels are spinning? And they're spinning in relationship to the z velocity. When I go backwards, they spin, backwards. It's a beautiful thing. One more thing that I wanted to show you from that script, now that that script is working and it's making the wheels spin, I can go back to that script and release that print just to show you what it would do if we let it, like show in the console, which was just a way of testing. So I'm going to clear, I'm going to play, and I want you to notice that it starts by printing all zeros. Let me, I clicked collapse, so it, so it doesn't print like, 10,000 lines, but just updates one line. As I start driving, look at what this line is going to say. It keeps updating 3 numbers. Those are the x velocity, y velocity, and z velocity. When I turn sideways and keep going, or when I turn sideways and accelerate and so on, it tells me exactly the vector, the speed. It's basically in meters per frame. And that's the z velocity, which we're using for a bunch of things. We're going to be using it for telling the wheels how fast to spin. We're going to be telling it, we're going to be using it for controlling the sound of the car and the pitch of the sound of the car, the volume and the pitch. Going back to the guide. Now, if it's working, save test, and we just did step number 22. And now we will create a third script. Again, in the scripts folder. We create it first, we attach it later. And the script is going to be called front wheel turner. Again, with a capital F, capital W, and a capital T. And instead of the default content, we're going to type. So I already did that. And again, it's in my scripts folder. What you would do, of course, is right-click, create, and mono behavior script. I already did. So this is going to be the front wheel turner. Make sure that the name is exact because the name of the class needs to match the name of the file. So let's see what this one does. Again, it starts as just a standalone script. Once it's nicely written, I'm going to attach it. Before I forget, let me go back to wheel spinner and turn this back into a comment. I don't need it to print all the time. But back to front wheel turner. The only library we need is the Unity engine. The public class front wheel turner, same as the name of the file, and it's going to have 3 fields or 3 public floats. 3 public fields. One of them is float called max angle, which is pretty much like, when I turn the wheel, what's the maximum angle that the wheel is going to turn? Now think about it. In a car, it's usually about 35 to 40 degrees. Cars don't turn 90 degrees completely sideways, only maybe toy cars. So usually it's like 30, 40 degrees, which helps us, make like normal turns. The other 2 are the game objects. Who to turn right and who to turn left. Which are the objects that are going to spin. Now notice that in this case it's not the tires but the whole wheelbase, and inside the tires spinning to its own forward. And on update, which means 72 times a second over and over again, it's going to find the target angle. What's the target angle? It's going to find input get axis horizontal times max angle. Remember, horizontal is a number that ranges from from -1 to +1. When we don't press any of the keys, it's 0. So when, let's say, I press and hold the left arrow, the value is -1. If the max angle is 35, then horizontal times max angle is -35. -1 times 35. So it's going to calculate the angle based on the horizontal value from -1 to +1. In other words, how much the stick is being bent sideways, or if this was a real car, how much, how hard am I spinning the steering wheel? And once it finds out, and it finds it with something called quaternion. Quaternion is a built-in method or built-in property that finds out the angles of objects in the real world, but it finds it in a very complicated trigonometry way with sine, cosine, tangent, and so on. What we need is to convert that to angles, like the x angle, y angle, z angle, and with the way we do that was something called Euler. So it converts the trigonometry into regular angles. What does it do? It goes, okay, whatever you told me is the wheel front right, it's transform local rotation, take that quaternion and convert it to regular angles. Euler, it's named after the scientist or mathematician who defined it. And how is it going to do that? It's going to say, well, actually, X don't spin at all. Y, we're going to spin, because think about it, when you are moving your steering wheel, you're actually moving the Y angle of your wheel. Again, think of a revolving door, right? Y plus 90, because the whole wheelbase is already -90. So it kind of straightens it out. And Z angle, which is like, basically like rolling forward, is going to be 0. Because the wheel's already spinning. Same thing from the front right and the front left. The 90 is because the wheel's base already 90 degrees Y. Let's look at it. If I select, let's say, wheel front right, it already has a 90-degree angle. And we did that in order to make the tires point forward. And it's Z rotation, point forward. So how's this actually going to work? We're going to go back to the guide, and we're going to assign the script to the vehicle itself. Think about it. The steering wheel belongs to the vehicle. And then add the following parameters, and we can drag or browse for it. The max angle, again, could be somewhere between 20 to 35. I'm going to do 35. So again, I'm going to take this script, which is the front wheel turner, and I'm going to attach it to the vehicle, saying, hey, vehicle, I just added a steering wheel to you. Not a physical one, not a visual one, but a functional one. The max angle, I'm going to put 35. We're going to experiment with different numbers. And then I'm going to tell it, okay, now when you move that steering wheel with, the arrows, who's going to actually look like it's turning? The front wheel right and the front wheel left. So as I open all wheels, I'm going to drag wheel front right here and wheel front left, not back right, but front left here. And the end result would be that when I play, even when the car is not moving forward, if I press the left arrow, the right arrow, or A or D, this will happen. Notice how it's making its way back, like, bouncing back. Why is it bouncing back? Because luckily, the horizontal axis, when I press the left arrow, it climbs from, let's say, when I press the right arrow, it climbs from 0 to 1, but gradually. And when I let go, it falls gradually. So does the wheel. 0, this is like -1, back to 0. +1, back to 0. We can experiment, for instance, by saying that, let me stop. what if the angle was 90? That would, be a little too extreme. It would mean that the wheels, when I press the arrows, would actually move 90 degrees. That's a little, too science fiction. So, of course, too much, not a good thing. Too little will not be noticeable. I just experimented and 35. Remember, all this is to make the wheels look like they're spinning. The actual movement of the vehicle was already established in the first script we did, which was drive main script. So now I can move this car forward, back, and when I press the left and right arrows, the vehicle itself turns, but also the wheels turn. Not just spin, but also turn. And now it feels a lot more like it. By the way, you can decide, and this is, totally up to you, that this is, there's cars that are front wheel drive and there's cars that are, rear wheel drive. Maybe the wheel for the back right and the wheel for the back left are the ones that are going to look like they're turning. It's not going to affect the movement of the car, but it's going to do this. A little weird, but doable. I'm going to return it to the way it was because I just like it better, visually. Front right is the front right, and front left is the front left. And going back to the guide, we just did this. We attached a script to the vehicle. We populated these fields. Test. Front wheels should turn with A and D or the keyboard arrows. Later on, when we build to Quest device, that's what the next step is about. If you have access to a Quest device, this is a good milestone to try building and using, the joystick on the controller. Make sure we've covered that by the end of the previous part. But if you're going to build, make sure you're building the stage you're on, file, build properties, and make sure, see how it says drive stage 1? I'm going to go open scenes list, add open scenes, and remove scene 1. So I'm building stage 2 because stage 1, the car didn't move yet. It's very easy to forget. So file, save, and file, save project. I believe this is pretty much the end of stage 2. And the way you're going to submit this, if you have access to a Quest device, great. If not, then we're going to build in class when we get to the right stage. But as far as like getting credit for completing this stage, you have two options. If you have access to a Quest device, you have your own. You're going to build, like we just build stage 2, see that it moves, and in the Quest device, capture a short video that shows driving. And it's very easy because there's a camera in there for capturing, like screen capture videos. Using the app, which is now called the Horizon app, you can transfer that to your phone and from your phone to your computer. If you're not sure, your future developers, Google how to do that. And then, of course, upload the video. What I'm trying to say is that I'm looking for a video, not the Unity project itself. No, do not upload the project itself. Too much. All I need is a video. And you're saying, what if I don't have a Quest device? In that case, do a screen capture video, just like for stage 1, you did a screen capture, like a still one. Now you're going to do a screen capture video of the way it looks, like what I'm doing right now. I'm on a Mac. I am using QuickTime to do screen capture. If I go back to the QuickTime player, there's a way to do a screen capture. Of course, it's right now recording, so that's why it looks like it's grayed out. I can tell you that on Windows, there's a ton of free tools that would help you do a video screen capture. One of them, by the way, is built into PowerPoint, if you got PowerPoint, but there's, free ones. So a screen capture of the whole Unity project and showing that you press play. If you never did a video screen of your computer, a screenshot of your, or screen capture of your computer, Google how to do that. There's so many options. What I will not accept, because that looks really lame and unprofessional, is saying, "Oh, can I just like take my phone and shoot a video of my computer screen?" No, that's gonna look really lame. In either case, you end up with a video, right? Whether that video was captured in a Quest device or that video was captured from, the screen of a laptop or a desktop. In any case, I want you to change the name of the video because, it'll get like a default name. I want the name of the video to be your name, Drive Stage 2, with whatever extension it will have according to the method that you captured it. Could be, an MOV, an M4V, and so on. And then upload it by the due date. I will see you in the next part of the tutorial, which will be part 6, and it will also mark the beginning of stage 3.